Hi everyone, and welcome to the webinar for the Building Dynamic Virtual Services in Minutes with the OpenAPI Specification. You're very welcome to the session today. If you have any questions, please enter them within the Q&A box. Just for some additional housekeeping, the session is also being recorded. And if you have any questions, please enter them in the chat box or in the Q&A box as well. We will run a poll towards the end of the session, so always interested in hearing your feedback. If you'd like to talk to one of our technical engineers for more demonstrations or more understanding of the individual products as well. So in terms of the agenda today, we'll cover an introduction into the OpenAPI driven development, benefits of API virtualization, overview of tooling, and the demo in more detail as well. So for anyone who's just joined, welcome to the session. So again, my name is Martin. I'm going to be bringing you through the webinar today, focusing primarily around the OpenAPI specification and then where we fit in with data-driven development, OpenAPI-driven development, and then around OpenAPI and virtualization. Okay, so let's into our introduction. So just to give an overview of Smartware and who we are. So we provide tools for development, testing, and operations teams to create great software faster than ever. We work with over 6.5 million users across 194 different countries and 22,000 companies. We're headquartered in Boston, USA, with 7, actually probably more, maybe 11 global offices as of now. Founded in 2009, and we are an open source innovator. We provide tools around UI test automation, API testing, API design, and then around test management, as well as performance monitoring and load performance testing, and many, many more. So when we talk about where our tools fit in terms of a general kind of design phase, when we talk from design, commit, test, deploy, and monitor, we can see over here on the left-hand side for design, we have tools in the areas of HIP test, which is around design features and tests for living docs with behavior-driven development. Then we also have our Swagger Hub tool, which we'll touch on a bit today. So this allows us to design, model, and share API definitions. And then you can see in the top left, we also have our Zephyr tool. So Zephyr was a tool on a company that we acquired late last year. So this has a native Jira integration, so Zephyr for Jira, and also provides on the enterprise test management platform as well. So really easy to use test management tool, allowing you to create your tests, have them automated, and then work across all your different requirements, releases, etc. And then at the bottom left, we also have our collaborator products. This allows you to do peer code document review, as well as artifact review as well. So then when we go into commit, obviously we don't have any tools in terms of a commit phase as of now, but we do partner up with the likes of Jenkins, the likes of many, many more different vendors, the likes of Bamboo, and a couple of different ones, as you can see here as well. So essentially you design your application or design your APIs or design your automation going forward, then push that into the commit phase where you commit and push new code, then kick off your tests from a CI perspective. Then that bringing into the test phase, we support the API layer and the UI layer. So we have tools around Test Complete for automated UI functional testing, Load Ninja, which allows us to automate UI performance testing, cross-browser testing to run Selenium and Appium tests in the cloud across multiple different devices. Then we have SOAP UI Pro, Load UI Pro, and Service V Pro. So these are all part of the Ready API platform, allowing you to run functional and security testing, API performance testing, and then virtualizing APIs, UIs, and web services like we will discuss today. Then we partner up in a deploy state with the likes of Docker, AWS, Azure, and many, many more different vendors to help you deploy to production once the tests and the builds have passed through. And then from a monitor perspective, we have our alert site tool. So this allows you to do global synthetic API monitoring for your APIs and web-based applications. So quick intro into the OpenAPI specification driven API development. There has been an explosive growth in terms of the OpenAPI specification, or OAS, as you can see on screen. So the OpenAPI is the standard for defining services. You can see here from a state of API report that we launched for 2019, over 69% of companies were using Swagger or OpenAPI in terms of the standard for defining APIs. So you can pretty much say that it's an industry standard in terms of defining your APIs, whereas not more commonly now, WSDLs and WADLs would have been used in the past. Pretty much now everyone is working on REST or going towards that vision of working on REST services. So we're, again, we're seeing that 69% in here as well. So almost half of the organizations have adopted a design-first approach. So you can see here what best describes how you work with the OAS today from the report that we released. So design-first approach, 25%. Both design and code first, 25 or 22%, and code first only approach is 20%. And then about 13% say that they don't use OAS or Swagger as well. So definitely we're seeing there, a big trend in terms of, a lot more companies using the OpenAPI specification. And, I would expect that to increase when we run this report for 2020. Okay, so what is the OpenAPI specification? It is a API description format for REST APIs. It's an OpenAPI file that allows you to describe your entire API. This is including available endpoints and operations on each endpoint, operation parameters, input and output for each operation, authentication methods, and contract information, license, terms of use, and other information. Okay, so sometimes it's also hard to understand what is Swagger and what is OpenAPI. So Swagger is this set of tools that's built around the OpenAPI specification. So you have your specification, and then you have Swagger, which is the tools that help you go ahead and design, build, and document these particular APIs. So we'll jump into that in a bit more detail. So why adopt a definition-driven approach? This allows you to go ahead and design, document, mock, virtualize, test, monitor, and consume based on the API that you are working on. So think about it, allowing you to do all of that within one specific set of rules based on the OpenAPI specification, making sure that you can go ahead and have that RESTful API, design it using the Swagger tools, document it using the Swagger tools, run your just general mock within Swagger, and then virtualize within the service V tool that we'll talk about in a bit more detail, test using the likes of SoapUI Pro, monitor using the likes of AlertSite, and then consume using the likes of Virt Server for the consumable piece as part of Ready API. So what are some of the benefits of definition-driven approach? This allows you to reduce interdependencies, allowing teams to work at their own pace, faster development and delivery. This is all around the area of faster development, easier expansion to different interfaces, clients, and views, developer-friendly services to build ecosystems and platforms. So really here we're focusing on faster development and new revenue channels that allow you to go ahead and have that explosive growth in terms of working on the OAS and working on the definition-driven approach as well. What are some roadblocks to achieving definition-driven approach? It's difficult to validate during design. There can be dependencies between teams, development bottlenecks, and managing versioning. So this is where we can go ahead and use tooling to be able to go ahead and improve and avoid these roadblocks or eliminate these roadblocks with definition-driven approaches. So what are some of the benefits of API mocking? You can remove dependencies with virtual services, increase delivery velocity, improve application quality, and reduce testing costs. So we'll take increased delivery velocity as a start. This will allow you to develop and test APIs in parallel. So when a spec is defined, you can get it virtualized in minutes so developers can begin working. So we'll show a real life version of how this works, but essentially you've built a definition within Swagger using the OpenAPI specification, Swagger Hub. It's a skeleton essentially. So it's just the design. You can go ahead and see exactly what it looks like. You're using that design first approach, but you actually want to stand up something that developers can, start working with directly, or that testers can start testing against in terms of adding in logic from a real life production like API. So that's where virtual services come into play, and we'll discuss in detail what's the difference between mocking and virtualization on the next slide. But really we're adding in different sets of responses and making sure that we can add the logic, making sure that we can see, okay, if there's a 200, if there's a 400, if there's a 404, etc. The next is improving application quality. Here you can go ahead and run end-to-end tests, integration and performance tests much earlier in the QA process and reduce the cost of bugs and defects. The last thing that we want to do is have to run all of these different types of tests towards the end. So where we can actually go ahead and import that definition directly from Swagger Hub into a tool like Ready API and Service V allows us to go ahead and actively work on that virtualized service, as it's going to be a production-like service as such. And also reduce testing costs, so allowing team members to test mission critical APIs and services at any time, any rate, without incurring additional costs. So we'll discuss again in a bit more detail when we show the demo, but we do have a feature within Service V along the lines of routing. So you can actually route to a live endpoint. So maybe it's a PayPal or Braintree, any of these different payment APIs, as I like to use as an example. We can go ahead and one time capture the responses of all of these, meaning that we don't have to use any additional cost, because if you're testing the live endpoint for any of these page or payment services, usually there's going to be an incurring cost every time you go ahead and use them. The same if you're working with a backend that's not really available, you can go ahead and again mock it or mimic it for one time and then go ahead and use the responses. So essentially you have a backend that is production-like and it's not available all the time. So again, it allows you to reduce testing costs and improve application quality, as well as increasing delivery velocity. So mocking versus virtualization, what do we see here as differences? So they do share a similar core purpose, act in place of a production API. So again, we're trying to mimic and see where that comes in. The depth is what separates them. So for mock services, this will typically have a single or small set of responses for a request. It is quite limited in context. It gives a wide number of open source and lightweight tools to enable this, typically script focus, and tie very neatly into CI/CD frameworks. So we take the example of SoapUI open source, or even using the Swagger open source tool. There is that availability to do somewhat of mocking within there. So being able to go ahead and generate a response based on something that you've defined in a spec for Swagger as an example. But again, it can be quite challenging or even not possible at all to make this response dynamic. So really this is going to be a static response. It's very difficult to say, okay, I have a number of different scenarios, and how can I go ahead and see what the response is like from different data sets, different behaviors, maybe I'm using authentication. So that's where virtualization comes in, and it really goes in depth between the two areas, okay? So for anyone who's just joined, welcome to the session. We're just going through a couple of slides talking about OpenAPI specification and how it works with behavior-driven development and I suppose OAS-driven development as such. So we're talking a bit about the differences between mocking and virtualization, where they come into play. So virtual services understand there is a context to part of the request, the weather today versus tomorrow, as an example for what we see on screen here with using the likes of Google Assistant. This returns a response from a pool of multiple different answers rather than just one static response. So we really want to limit the amount of scripting involved in a virtual asset Virtualization should be flexible to be updated and changed as required, so adding in logic as such, and it shouldn't look too much like a real service. Would we ever want it to query a database or integrate with a third party as such? So what we're talking a bit about virtualization is more that, okay, we have a set of different responses. Maybe we want to go ahead and pull data from a database, JDBC connection, maybe from an Excel sheet, maybe from an XML or a JSON file, and we want to pump that into our response rather than having it as static. Because think about it, if you have a parameter and that parameter is equal to a certain value, you want to return the correct response from here. So you want to make sure that you're adding in as much logic as possible to make it, as realistic as possible from here. Okay. So where do we talk about the tooling that supports each of these kind of problems that we talked about? So Swagger Hub. Swagger Hub is SmartBear's platform solution for designing and designing and documenting APIs, bringing together all of the open source options from Swagger, so including Editor, Swagger UI, and CodeGen, but again, focusing a lot more on the collaboration piece as such. So this provides structure and guidance. You can go ahead and select to create teams or organizations. So, maybe one organization will have a team. You can go ahead and separate this into projects. We also have a really, important feature called API standardization. So this is allowing you to set a set of rules to make sure that in order for the API to be publishable, you can go ahead and make sure that the standardization has been met in here. So the standardization could be around operations, it could be around models, it could be around schemas. If someone is using underscore, someone is using camel case, you want to make sure that they're using the correct one that is appropriate to your team and to your API standardization. We also have the option of using domains. So domains is like a reusable component where you can go ahead and specify authentication or maybe using a login, as I like to use as an example, and then reuse that across multiple different APIs. So all you're doing is a $ref, and then you're selecting your domain rather than having to type it out each time in terms of a path or in terms of a schema within your actual spec. So we see Swagger Hub as a single source of truth for distributed services. So CI/CD can call an API, developers, architects can work in the same space. So it's a fully collaborative platform that allows you to design, develop, and document your RESTful APIs, and then go ahead and use the likes of auto mocking for static mocks as well. So where does that fit in with our tooling for virtualization? So our tooling for virtualization is Service V and Virt Server. So Service V and Virt Server allow you to create virtual assets in seconds using manual creation, definition-driven creation, so importing directly from the OpenAPI specification definition that you have, and then go ahead and build a virtual service from here. You can layer in logic for contextualized responses. So I mentioned earlier about adding in the likes of parameters, making sure that a parameter is meeting a specific response. Easily parse out request data to be returned in the response. Share virtual assets across larger teams and organizations using Virt Server. So Virt Server essentially sits on top of Service V and is used in a deployment perspective. So you can have this sitting on a cloud-based machine. You can have it sitting on a virtual machine or even another physical machine that's dedicated to where larger teams and organizations can go ahead and access these APIs that you've designed. So where do they fit together? So if we look on the left-hand side, we see that Service V provides a working version of the API design. So think about it, you've designed your API within Swagger Hub. It is essentially a skeleton. You can go ahead and in Service V, make sure that this is containing all of the right logic, all of the right responses, all of the right information to have it as a working version as such. This alleviates what we can offer and share beyond our documentation. It also provides something tangible behind the Swagger UI documentation. Instead of reading what the API actually does, we can start working on it directly. Application dependencies and integrations can be fleshed out with more confidence. Feedback and changes can be made and revalidate it very, very quickly. So you can actually update the definition. You can go ahead and refactor. So if you do have new versions of the API design, this will go ahead and fit directly into Service V and Ready API. So this can be done in a fraction of the fraction of time it can take to code, even with the SDKs. So we have an awesome capability within Swagger Hub, but there are a silver of what is possible with a tool like Service V. So I'll show the differences and how these two tools actually integrate, and I think it goes through this a bit more on the next slide. So we see an example here of Swagger Hub, and then Service V on the right-hand side. So you have 3 different teams working on design, document, and build. Within Swagger Hub, this essentially brings it all together. When we jump into actual Service V virtualization, this allows us to pass in the API definition and then go ahead and have our verts sitting on there as well as deployed virtual services. So definitions get pushed to a centralized store. Virtual assets can be created and deployed as needed. Vert server exposes these at an organization-wide level, and gateways can be layered over the virtual assets to mask what's going on under the hood. This will probably make a bit more sense when we jump into a demo, and I think we're about to jump into the demo. Okay, so guys, if there's any questions that you may have, feel free to enter them within the Q&A and or the Q&A box or the chat box, and we'll try and get to them during the session as well. Okay, so what we see on screen now is Swagger Hub, essentially. So this is going to allow us to view our documentation on the right-hand side. We have our spec here in the middle, and then we can also search for a specific resource path on the left-hand side. Now, what we can do when we talk about API auto mocking is if we look at this get pep by ID, we can go ahead and pass through a parameter that we've defined inside of our spec, enter the value of 0. This will go now ahead and give us a curl command. We can go ahead and use that anywhere, again with the request URL if we wanted to use that in terminal, and even sync it with gateways like Kong, etc. We can go ahead and start working on this actively. We're just giving our developers a guide to, okay, this is a mocked example. Now, this is a great feature and a very heavily used feature of Swagger Hub. What is a limiting factor is that you are getting a static response in this case. So in this case, we have our name string, we have our name doggy, but we can't really go ahead and change that automatically. This is what is defined in our actual spec. So this may be a case where testers or developers want to go ahead and select different ways of doing this, pump in different types of data from Excel sheets or JDBC connections, etc. We see examples with banking clients often about passing through different credit card numbers, different account numbers, etc., rather than just testing one on the fly. Obviously, we want to go ahead and see what this looks like, getting our 200 okay, and getting the response body, all of our different response headers, as well as that the duration it took to actually send the response, and then look what happens if we get a 400 or a 404 as well. Okay. So just in Swagger Hub in detail, in a bit more detail, this is my hub. So we can actually search by standardization, which I talked about in a bit more detail earlier. So we can set standardization rules from our organization. So you can see here on the left-hand side, I have 2 different organizations, SmartBear Melbourne, SmartBear Software, and I can go ahead here and select different projects underneath all of these. I can work on Swagger 2.0 or OAS 3. I can select an API or a domain, so domain being that reusable component that I talked about earlier. We can select the visibility to be public or private, the state to be published or in a draft mode of unpublished, and then the owner to be the individual user or the organization as such. So just to look at some of the different features within inside of my organization, one I wanted to highlight was around standardization. So here you can enable the API standardization for this organization. You can require the API to pass the standardization in order to be publishable. And then you have items here around API info and then operations and models as well. So the likes of summary should start with uppercase and then with a dot. All model properties must have examples. So there's a number of different standards that you can go ahead and set here for your organization, meaning that each rule will be applied to the API API definitions that you have. Okay, so where do we go ahead and fit this directly within our Service v2? So let's take an example of this demo that we have here. So this is our Swagger pet store, very commonly used. We can go ahead and make sure that this is working. Let's remove this. Okay, so we can just let us save that. Yeah, that's fine. So now we just want to export this into a format. So we have our client and server stubs. So I can generate it into a client SDK based on, Groovy, JavaScript, Objective-C, Ruby, if you're working with Swift, etc. Server stub can work with the likes of Python Flask, Node.js. We see a lot more working with different stubs all the time, Go Server, Haskell, and even Sinatra or Spring as well. We can also download the documentation in HTML or HTML2 format, as well as CWiki. But what I want to do in this case is download the API in a JSON format, and then we can see how we can import this directly into Service V. So just go ahead and we'll take this Swagger file. I'm just going to sit it on my desktop. And then we can go ahead and jump into our Service v2. So this is Service V. This is part of Ready API, which is part of SoapUI Pro, LoadUI Pro, and Service V Pro. So SoapUI Pro for functional testing, LoadUI Pro for load testing, and Service V Pro for virtualization. So what we see here at the moment is my virtual services that are sitting on my local machine. In this particular project, there is none. We also have our Virt server, which is all of my deployed virtual services. So this could be sitting on a cloud-based machine. This could be sitting on another virtual machine or physical machine. At the moment, this is just sitting on my machine, my laptop at the moment, but I have an IP address here that I can go ahead and use as an endpoint and then just define my resource path in this case. So we'll go ahead here and add in a virtual service. We can select from a definition. We can actually record a protocol from SOAP REST. We can then also create an empty SOAP REST, JMS, JDBC, and TCP. So you can actually go ahead and have a virtual service of a database. So you could go ahead and then reuse it and go ahead and create all these different responses from here as well. Record allows us to actually record traffic to create a virtual service. We can also then route to a live endpoint and then capture the responses as well. So there's a lot of different ways that you can focus on not only OAS driven development, but also focusing on creating a virtual service from scratch as well. But from here, I'm going to select Swagger or OpenAPI. This is going to ask me to provide the definition file. Just going to select it on my other screen from my desktop. Should have our Swagger file. You do. Now you can see that this is my Swagger JSON file. We can then select the different resources that we want to go ahead and create as part of our virtual service. We'll give it our name, and then we'll give it the port that it will sit on, as it is a local virtual service. Now you can see that we have our virtual service from here. So this has all of my different operations, get pet by ID, posts, etc., put, number of different resources, and I can go ahead and start working actively on each of these as well. So we'll take that example of get pet by ID, this one here, and we go into our editor. And just to move this over a bit, so we can now see that we have what we had directly within Swagger Hub. If I just jump back here for a moment, find pet ID, we have our JSON response here as well with our static values, doggy, and then ID 0 string, and it's also available. So this is being carried over from our definition, which is great. But what if we wanted to go ahead and make a couple of changes to here? So let's say we have doggy and we want to go ahead and pass through different values from a data source. We have what we have up here is our data source. We have authentication, transaction log, and we can also mimic behavior. So initially I want to select my data source. We're going to call this data source 1, and we're going to add a property called pet ID. And then I'm going to select this from either an Excel sheet, another file like a notepad, from a grid where we can enter the data manually ourselves. So actually, let's go ahead and do it that way, or else I can select from a data generator as well. But maybe in this case, I want to select example here called cat. Select another one called parrot, and maybe something called ferret. So we have a couple of different options in this case as well. We've gone ahead and typed these out ourselves, but you can also select from an Excel sheet. You can go ahead and generate data on the fly. So how we can use this within our actual response to make it more dynamic is select that data source 1 down here, and then instead of name inside of our commas, we can right click by removing, and then point to get data, and then point to property pet ID. So now this is creating us a mocked response, meaning that if we were to go ahead and point to localhost port 8088 and the resource path, this will go ahead and sequence through all of our different examples here as of cat, parrot, and ferret as well. So let's see if we can go ahead and point to this. And just try it from here. Okay, let me see. Make sure this is working. Okay, we're just getting a 404 in this case. From here, see why that's happening. Okay, let me just try one more time, and if not, we'll just go ahead and move on. Actually, we might just try another host. Call this localhost port 8082. I think I know the problem. Okay, now we can see that we have cat. We refresh again. We have XML in this case. We go ahead and get our 400, 404, etc. And then we can see now that we have parrot. We'll generate this in XML for doggy. And then again, we're sequencing through our 400s and our 404s, etc. And now in this case, we have ferret. So you can see that this can be done absolutely, but it can be quite difficult when we use this sequence mode from here. So this is why we have different dispatch styles. So dispatch styles can be in the areas of random, query match, script, or parameter. So if we use the example here of parameter, I can say, okay, if pet ID is equal to parrot, or let's say cat, then send the response for response 1. And if query pet ID equals to, we'll say 0 as well, or we'll say available. Actually, let's change that one more time. Status is equal to available. Then send the response for response 1. So this means that we're adding in a bit more logic, making it, rather than sequencing through all of the different responses, we're actually adding in some logic here to make it as much of a real life like scenario as possible, meaning that we have, you know, a very, very virtualized service that is as real like as a production like system. We'll always set our default response to response 4 or response 5. So these would be what we're showing in terms of a 404 or a 400. But we can actually change the HTTP status code. So maybe for that response 1, we're always getting a 200 OK, but I wanted to go ahead and maybe change this to a 400 or a 500, so we can go ahead and change the responses any way we like. So think about it. You are testing against this, you're a developer, you're working against this. You can then change the way that the actual virtual service will work according to the way that you have it designed or the way that you want to have it actively working as well. So there's different responses. You can change these. You can go ahead and add in JSON or add in XML itself, and then start working directly on that as well. So it's a very customizable feature and a very customizable tool, Service V Pro. You can see in this example for response 2, this is all based on XML. Again, I could go ahead and pump in the data source to here, so passing through all of these different values as well, and then base that on a specific parameter, logic, script logic, XPath, query match, or go ahead and do it from a random perspective as well. So at the moment, this is going to be sitting directly on our localhost port 8082, but maybe we want to go ahead and deploy this to our Vert server. So you can see here that this is actively running. We have our Vert server up and running here at the bottom. We can just drag and drop. Now we can go ahead and see that this has been deployed, but it may need some fixing in that case, which is fine. So we can then see our Vert server. So Swagger Pet Store Virtual Service. Where do we put it? Yeah, here we go, down at the bottom right. So now I can go ahead and have this started, and then I can go ahead and have consumers going ahead, or other teams even, going ahead directly working on this, start testing against it, start working on it directly as a developer. So it really makes it a lot easier when we talk about deployment. We have that parallel development between Swagger Hub and Service V and Vert Server, making it actively easy to go ahead and take a skeleton of a design of an API and then go ahead and create a real life-like system. All right, so that's pretty much what I wanted to show from the deployment side of things. A couple more features around Service V. We can also mimic behavior. So the likes of hardware capacity, network bandwidth, and we can start sending error codes. So we can go ahead and change the minimum threads, maximum threads, our response delay, change the connection bandwidth in terms of megabits per second. And then we'll just say for 1 minute or 2 minutes while we're testing or working against this API, we want to start sending 400s or 401s with a message body to say, okay, API is down, API is not available, as it may happen in a real life-like scenario. So this is helping you be prepared if something like that does happen as well. Okay, so interested to see if there is any questions from anyone on the line. If not, we'll continue to move forward. So in this case, you can also use required authentication. So if you were using the likes of OAuth or basic NTLM, any of these, you can go ahead and then use the authorization within your virtual service as well. Okay, so that's kind of what I wanted to show in terms of the demonstration today. We covered a bit around the setup of what the OpenAPI specification is, how does it fit in directly from Service V and from Vert server as such, and we jumped in and had a look at importing the definition directly into Service V, working with responses, editing responses to add in a data source. We showed our example here by just pointing directly to our local host port 8082 and then generating our JSON by going ahead and, I suppose, pointing directly to our data source and what we've gone ahead and changed by using a sequence. And then we looked at deploying this to Vert server, as we showed here from here, and then how to go ahead and point directly to that by using the endpoint here, which is our IP address. And then we also looked a bit around the other configuration within the setup, the behavior, the authorization, and all of the other different formats from here as well. So definitely I'd recommend taking a look at Swagger Hub. You can just go to swaggerhub.com, and also for Ready API, you can just go to the SmartBear website and then search for Service V. It's on the main page of our website as well. And Ready API as well is where SoapUI Pro, LoadUI Pro come into play as well. So I'm just going to run a quick poll at the end just to see if anyone wants to give some feedback. Are you interested in speaking to a member of the team around how SmartBear tools can accelerate API development. So again, if you're also interested in talking to one of our team around this, that would be also great. So I'll leave that open for just a moment or two. Okay, so thanks very much for joining the session, guys. I hope you all have a great day. And again, this session was recorded, so it will be sent out in about 24 hours to 48 hours after the session. So thanks very much for joining and have a great day.